The next topic, the introduction to the Cisco network and Cisco iOS commands. We're going to take a look at some basic configuration commands and some aspects of the Cisco iOS, the Internet Operating System that it uses for these things. The Cisco common network components, we're going to have switches and routers. And as you configure these things, please, take away the commonalities of the iOS. The structure is very similar. The commands are very similar, actually they're the same. We just don't have everything on the switch that we have on a router, or we don't have a MAC address table, for instance, on a router. So if you show MAC address table on a router, it's going to tell you that no, we don't have that. If I was saying to me, it'd tell me you're an idiot to do that. It provides the desktop access, and that's only for me, but it will not respond to those things. I'll try to show you some of what this works with. But the switches, desktop access to the access layer in the 3-layer Cisco hierarchy, enables segmentation of LANs into virtual LANs, VLANs. We will do VLANs. We probably won't get up to them tomorrow. Probably Wednesdays when we'll get to the VLANs, virtual local area networks. The Cisco Catalyst switches in the 3-tier model, the layer 2 switches can be they're at the access. They can be at the core layer, but I think that what you'll find at the core layer is going to be layer 3 switches because they're going to be much higher speed, and that's the objective of the core layer. In the collapsed core, the one where we didn't have all of the devices, layer 3 switches are going to be used at the distribution of the core layer. We have to use layer 3 switches because they have a routing capability to do that. Routers are going to be at the distribution layer if we use all 3 of these, and they're going to connect local area networks together, IP networks together. It could be LANs or it could be wide area networks to do these things. More connections, bigger router. If we have more data to process, the more expensive of a router we're going to need for these things. Going to have varying speeds, and I don't know why it opened over there. I was just trying to get ready for the next thing. You're going to have varying speeds for these things. Let's see, let me get rid of here. More connections, varying processor speeds and interface types. The devices are modular, and I'll try to show what that is here in just a second. Common interface enables an inexpensive upgrades, and we might as well look at that here real quickly. If we bring up, let me drag a router up here. Let's do a 2811. This is simulated, obviously. I'm going to turn it off because I can't do it if I can find the power switch on it. There it is. What we have on the back side of the router is we have, in this case, they're just open holes. We have modules that we can add to these things. If I want to add here a WIC2T, which is going to be some serial connections, and you can see the dual serial ports for these things. We can add them. If I want to add and this features 4 Ethernet ports, a little bit bigger, I can put it in this one. And let's see, the 8. Yeah, I can't do that because I already filled it up. But the different modules, these are modular, and this would allow us, if I put more serial ports in here, would then allow us to modify the device, upgrade the device, or if one of them fails, we can replace them because we just take one module out and put another module in. It's got a couple of screws, that's it. If you don't have them, they don't come with big holes in them. They come with usually knockouts over the modules that you can take out and then put the modular holders and then put each of them into the system. I'm going to just move this over. I'll bring this back when we look at the iOS, when we'll look at some on routers and some on switches. So Common interface is easy to upgrade. The iOS itself is a proprietary operating system. Runs on Cisco devices, Cisco switches and routers. It also runs on a desktop using the GNS3 software if you want to practice. Packet Tracer is the Cisco program that was designed by Cisco to support the configurations that you need to learn for CCNA. I use it because I've used it for years, and it's easier for me to do. I can build an infrastructure pretty quickly on it. I can go get a router or whatever I need to put on it, and it supports all of the commands that you should need to be able to know about for CCNA. And it's free. Provides connectivity options for carrying traffic between the devices. These are what the iOS is going to do. Network protocol implementations for the upper layer and the routing support that is going to go on with the devices. Security options to control access. And these are all things that we'll configure as we go through the course itself. Scalability options to add capabilities as the network grows. Reliability options. High availability and dependable network access. Again, more things that we will do some configuration with. The operating system itself is broken down into different layers. I'll call them different layers, different modes, and each of the modes is going to have a little bit different capability. Let me look at the slides, and then we'll go look at some configuration that goes on with these things. To use the CLI for viewing the status or changing its configuration, we got to be in the proper command line mode. And different commands are going to be available in the different modes here. And I'm going to show you in a minute how to figure out what's going to be there. The three primary are user exec with the greater than symbol. You can't do a whole lot here. The privilege exec with the pound sign, and each of these routers, that's the name of the device, with the pound sign, privilege exec mode. Privilege should be a tipper that, yeah, this is a much more powerful mode. When we get to it. Global configuration mode, the pound sign with the config in parentheses. Global configuration changes this configuration on the whole device when we do these things. And then we have the interface configuration mode down here, config IF for these things. Global configuration, specified configuration for the entire device. The first two are checking device status, and then the interface down here, we go to a fast Ethernet or a gigabit Ethernet or a serial port. We put an IP address on it. We could change the type of encapsulation that's on it when we do these things. So the interfaces that we have are the physical interfaces, the VLANs, the VTY, the virtual terminals, the Telnet SSH terminals, the console, and then the router, the virtual VLANs. Interfaces that goes on. When I want to, and this says end, if I'm down here and I want to go back to jump right directly back to the privilege exec mode, I can use end. If I want to move up one layer at a time, I use exit in order to go from one to the other. These are the kind of things, you play with. The labs do some of that. Some of it is just go play with these things. So what can we do here in the user exec mode? Statistics about the basic functions of it. Basic management functions, not very many, but clearing counters, resetting terminal lines, a subset of available iOS commands, a very small subset. Basic troubleshootings, we can use ping and trace route, telnet from this command, and some show commands. The show command is going to be your big time troubleshooting command. It is one of the primary troubleshooting commands. We can show a lot of things that goes on with it. The privilege exec mode, and this is where you're really going to be able to see things. Perform the executive functions, the executive functions here. View change configuration information, clear counters, manage the operating system, start the command line editor, and issue the command to move to a global configuration mode. And that's where we're going to be able to make changes to things, and then interface configuration mode. These are the ones that I want to look at here in a minute after we look at some of these things. The command line modes, the user exec ping and the privilege exec, and these are kind of broken down into each of these. The prompts, the user exec, the router, the privilege, the interfaces that go on with these things. Let's see, user exec, and these are what I want to do is I'm going to demonstrate, and then we'll do these. I want to demonstrate these commands. The first thing that we have to know is that these devices don't have keyboards, mice, or monitors. So we have to connect to the console port. In Packet Tracer, this little blue line here represents the console port, the rollover port. And we'll connect from the RS-232, the serial port, to the console port. And this is you can see all of the ports that are available on this thing, all the stuff that I added to it. We have a bunch of serials, and we have the original two Fast Ethernet 00 and Fast Ethernet 01. Once I do that, and I don't have to actually go and start putty on this thing, I can go to the desktop and just click on terminal. The defaults here, the port configuration, bits per second, 9600. The data bits are 8, parity is none, stop bits are 1, and then flow control is going to be none. We do OK. I'm now connected to this device, and this says what I like to do in initial configuration mode. I'm going to say no to do that. So we're in the user exec mode. In the user exec mode, if I want to see which commands are available, I just simply type a question mark. So when I said not very much can you do here? We can do a connect, open the terminal connection, disable, disconnect, enable, exit, log out, ping, resume show. And the show commands, if I want to see what's available there, those are the things that I can show. So I can use some of the show commands at this level, but the big one that way I can use is if I type EN and then tab, it'll do command completion for all you Linux guys. It does command completion. This is based on what's the programming language that Linux is based on. But if I type the question mark after the EN, it'll come to me. After the EN, it tells me that all of the commands that are available that start with EN is enable. So it's a unique character string, and we can then just use the tab key and it can complete it. If I do E and I try to do a tab, it doesn't work because there are two commands that start with E. If I do EN, tab, it will complete it. This is one of the things that you can use that at the right level to do these things. Enable gets me to the privilege exec mode. We have the pound sign here to do this. If I do the question mark, I have a whole lot more commands that are available in the privilege exec mode to do these things. One of which is the configure, and I can go to config T, config, CUNF, and then tab, configure and T terminal, because I'm at the terminal. So I'm in the config mode. One of the things, let's do a command here, host name, and let's call it CCNA. When I do that, the name of the device immediately changes for that. And then I could go to the interface, serial 010, if that is actually one there. It's an invalid. Do show IP interface. Brief, let me get one that is actually real. I thought I had some serial. Yeah, serial 00. 0. So let's go to interface serial 0/0/0. And now what can I do here? These are all the things that I can do on the interface. Let's do an IP address. IP address 192.168.2.1 in the subnet mask. What I now have to do is use the no shutdown command. By default, all of the Cisco devices, it changed state to down because it's not connected to anything. All of the Cisco devices are in a shutdown mode when we do those things. And I can show the IP interfaces, and then what I can do, the amplifiers for that. Fast Ethernet gigabit serial. Let's do the serial interfaces, incomplete command. And say serial, what? It was 0. Which one did I use? 0, 0. Shows me the information about it, the address that I put on it, the maximum transmission unit, information that you might need. If I want to see an abbreviated look at the interfaces, I'm going to show IP interface brief, and this just shows me the interfaces that I have. Administratively down means that we have shut this thing down. This one, we have a down, and the reason it's down is because nothing's connected to it. I can't bring it up because it has to be connected to something at the other end. The user exec, not a whole lot that we can do there when we look at that. The commands that are available, if I bring a switch up, and I'm going to cheat after I bring this switch up, switch down here at 2960. What you can do in Packet Tracer is use this thing called CLI, the command line interface, which isn't going to happen on a real device. The reason I started out the first one there, we've got to actually connect to it using a piece of cable, the rollover cable, the console cable that we talked about this morning. Looks very similar. Enable, and we can do configure terminal here and do the same hostname command. Let's say CCNA switch, and works the same way. The iOS's routers to switches, the commands that are available are going to be a little bit different obviously, but the way we do them are going to be the same. When I have made these changes, which I just did, they're in memory. They hadn't been saved to what's called NVRAM, non-volatile RAM. So since they're in volatile memory, if something happens to the power, something happens to the device, the configuration goes away. Well, the one that I did is not such a big deal. I can go back and type CCNA switch for the host name. But let's say that you've got 200 or 300 lines of configurations there, and then you have a power failure, and you haven't saved them. The way you save them are two ways. One is write. The one is copy the running configuration file running in memory, to the startup configuration file, which is stored in non-volatile RAM. The quick way to do it is just use the write command. And now, if I show the startup configuration file, I have information there, and I did see what the host name is the only thing that I can figure on this thing, right? Yeah, the host name here is CCNA switch. We have those capabilities. So let me let's look at the slides and see what I missed in that. User exec, view statistics, basic router functions, very basic router functions. Basic management, clear the counters, reset the terminals. When we did the question mark to look at the commands, there were relatively few commands that were available there. Limited subset of commands, ping, trace route, telnet, show, not a whole lot can happen there. The big thing that you can do is get into privilege exec mode. It is represented by the name of the device and then the greater than sign. The command prompt is the greater than symbol. the privilege exec mode accessed from the user exec mode by en or enable or en tab. Enable is the full command that we use to get into this mode. Privilege exec mode, all the user exec functions, each layer, as we move up, we can execute the commands that were below it. Well, kind of we can. In this case, we can. Full access to the device allows all the user exec mode commands. Additional commands are available here. And again, same way. What commands can I use here? Question mark. Don't be afraid to use the built-in help. That's what it's there for. The tab, the question mark, all of those things are available. And when you're doing labs, you'll have a whole lot fewer typos if you use the command completion with the tab key to go from one to the other. Additional commands here, necessary step to the global and the interface configuration modes. So we do the enable command. The pound sign is what represents the privilege exec mode. Global configuration, access from the privilege exec mode with the configure terminal conf t. Show and write commands start with do here. What that means is if I am at a level that I want to do something that I can't do, and I want to go back to the router for that. The terminal, and let's go to config T, and I want to show the running configuration file. Show run, question mark, unrecognized command, because it's not here. The show commands that we can do here are none of them. But if I don't want to move back and forth between these things, I can type do, show, run, and it will show me the running configuration command. So do in front of the command allows you to run it at the improper mode that we have with these things. I probably want to move that off because I will make a mistake if I don't and close things out. So the show and the write commands start with do. Write, you can usually use copy, run, start, or the write command in order to save the configuration to NVRAM, the non-volatile RAM. Global configurations used to change the configuration pertaining to the entire device. We did that with the host name to be able to, and it applies to the entire device when we do these things. Let's see, this mode is indicated by the config and then the pound sign when we do those things. The interface, we went to the interface configuration mode, access from global configuration mode. We have the line, the console line, the VTY, the virtual terminal, the telnet line, and the aux. The aux, again, is designed for out-of-band management, a modem, for instance, plugged into it. The interface Ethernet or serial, we did that. We could also use the interface VLAN in order to be able to configure these things. Changing the configuration for a specific device, enabling interface on an interface configuration mode. And maybe we should do one just to see that, yes, we can do these things. Let us configure a Fast Ethernet 00 to a device over here, Fast Ethernet 01 on this thing. It's red. The solid line here represents a straight through cable. The dashed line represents a crossover cable. So I already get Fast Ethernet 00. So I want to make one come up. So let's go to interface Fast Ethernet 00 and do IP address 192.168.2.5 or 4. It doesn't really matter. Then complete command because I didn't do the subnet mask. And now overlaps with serial 00. Oh yeah, we're going to have to be on a different network. So let's go with 3.4. So you see, well, it'll tell you when you make those kind of mistakes, the IP networks will overlap. And now let's do a no shut. When I do that, let's use the do command. Do show IP interface brief. This one now says the status is up and the protocol is up. The status is layer 1. The protocol is layer 2. This one is still down because I don't have the serial port connected to anything. All these others say that they are administratively down, which means that after I configure them, I have to give them the no shutdown command in order to bring them into an up status when we do those things. Configuration for specific, enabling the interface, logically done in the interface configuration command. The show commands here again start with do. We can use the do command at these things. The mode, this mode, configure interface, configure line, configure router when we start doing routing protocols. Configure VLAN when we're actually doing VLANs with it. The operating system components, the router components, we're going to have RAM, the running configuration file. The RAM here is going to be volatile RAM. That if we lose power, somebody turns the power out, turns it off, trips over the power cord, whatever else, all of the information loaded in RAM is going to go away because it is volatile RAM. Flash in iOS for file storage. Flash is where the operating system is stored on the device. ROM has the bootstrap, just like in a computer that you're done in A+. We're going to have a bootstrap, which is going to, the basic commands that are going to get the system going into the boot process. Non-volatile RAM is where the startup configuration file is. The start sequence would go ROM, finds the iOS, the operating system, in Flash, loads it into RAM, then look to see if there is a configuration in NVRAM, non-volatile RAM, and if there is, it will load it. Two ways to get started. We have the normal start sequence and then the setup. And when I did that one router, it said, do I want to do that? There's going to be a lab later on where we will do the setup, and I don't know why they did it later, but they did. The setup command where we can do some really, really basic configuration. And after you do the lab, hopefully you'll never have to use that particular one again. And then the copy, run, start, or the write command in order to save the volatile configurations to the non-volatile RAM, the NVRAM. Disk storage. It's not disk. This is similar to a flash drive. We would use there. The configuration register is a 16-bit hexadecimal number, and what it tells the system is where different things are. Where is the operating system stored? It does not have to be stored on the device itself. It could be stored someplace else. It could be on a TFTP server so that it gets uploaded to it every time that we start the device. The boot field, and these are what you really need to know about. These are the configuration register, and we'll do a password reset. 2102 is the normal boot. 0 is the ROM-mon mode, RX boot, F boot. What this says is boot from iOS. Look for the iOS in flash memory, and then look in NVRAM, non-volatile RAM, to see if there is a startup configuration file. 2100 boot to ROM-mon. 2142 is ignore NVRAM, which we would use if we needed to do we forgot the password, or somebody put in a password that we don't know. We'll ignore the NVRAM because that's where the password would be stored. The non-volatile RAM, the startup configuration file for these things. This is if you want to look at what the bits mean, the config register, and how you would change things are on this slide. The basic ones over here were in the other one. 2102 loads the iOS from flash and then the configuration file from NVRAM. The router looks in NVRAM for the boot sequence, load ROM mon mode, mini iOS 2142, the iOS from flash, and do not load the startup config file. How do you find out what it is? If we go into this thing and do I picked the wrong one, and then not run, but the terminal, go into this thing and let's do an in here. I'm going to do a show version. The last entry in the show version command is the configuration register. Other things that are in the show version, here we have the processor, how many with the Ethernet ports, the fast Ethernet, what's there, how much RAM do we have, and the bytes of board processor for flash memory. If I do a show flash, let's see if I show flash, I can see the iOS here, and this is the title of this iOS, the operating system that's there. Let's see, show NV RAM is, that's what I thought. Control-Shift-6 is the break sequence for this one. I want to do a dir. We have a directory here for flash. Oh, I didn't, no wonder I never saved this one. I saved it on the switch. So if I did a copy, run, start, and then show flash, and then the categories available. We do a directory here, and it's not programmed in this directory NV, yeah it is. There's a startup config file. I'd use the dir command. Not everything is actually programmed in Packet Tracer, which gets kind of confusing at times. If you try to do things like that you wouldn't have to do for the CCNA. The boot process, and you had, those of you who've had A+, you did the boot process. We have ROM, we go through post, performs the post, loads the bootstrap, executes the bootstrap loader. The bootstrap loader, where we're going to find the operating system, and then it goes to flash, locates the iOS, loads the iOS, and here it could be in flash or TFTP depending on what the configuration register tells it to find it. After it loads the flash or loads the iOS, the operating system, then it looks in NVRAM or TFTP server for the configuration file, if there is one. If there isn't one, we'll go to the console. We'll go into the setup mode. Do you want to go into setup mode and use it in order to start up the system? And the answer there, could be a yes or could be a no for that. Some basic commands that you'll use in these things, and this is using the netsim show version, show commands that you'll use. Let's see, let me see where we are here. The basic commands that we're going to use. Let me go through the troubleshooting methodologies here, and these are not going to be anything dramatically different than you used in any of the CompTIAs. We're going to define the problem, gather the information, consider the probable causes, devise a plan, implement the plan, observe the results, repeat the process if it doesn't resolve the problem, and document the changes once we have fixed the problem. What did we actually do to do it? Debugging commands, the show command, the debug command. The debug command is one that's kind of nice to try to use, and we'll look at it as we go through. There used to be a debugging lab that you could do, but they moved it into CCNP. If you want to play with it, you can play with it in Packet Tracer to do that. Details similar. The show command is a static image. The debug command tells you what's happening on the device in real time. Let me see if we can do something here, just a quick, to kind of demonstrate that it is an in motion thing. I want to do I think I've got a rip here so that we can see some route table being passed from one to the other. Let me see if this one says done. So with this, let's just go in here and see if we can do a cheat and use the CLI. And you do it from debug iprip. iprip won't work. Debugging is on. When it starts exchanging, there we go. It tells me what says building the entries, sending the entries, where it got it from, where it's sending it to. The debug command displays for you what's actually happening on the router. The show command displays for you the static picture of what's going on. Show IP interface brief when we do those things. Continues running based on the options until we use the no debug or the undebug. Generally, the way you undo any Cisco command is no in front of the command. So no, whatever, I made a mistake, I can go type no, copy the command, and then paste the command and undo it. So no in front of the command will undo a Cisco command. No debug all, undebug all, or u all, are all ones that are there. The undebug is one of the few commands that you can use that doesn't have a no in front of it to undo things. This is just the show processes, and it just kind of gets thrown in here. The processes that are running on the system to do these things. Log files. Show logging is the way that we would get there. The show logging command, the buffer erased at a reload, and I think that there is a lab for logging. And we'll talk about logging later on and how to use a syslog server, configure a syslog server, look at a syslog server. But by default, it's going to send the logging to the console port, which is when we connect to the console cable, we're going to be on the console port to do those things. Apply the filters, and then the remote sessions might not display all of the error messages for these things. Different commands, the basic debugging, the commands that we can use to do the debugging for this one. And this lab, again, is not available anymore. The interface issues, few of these, and then we'll get into the lab world here. But common issues: bad or damaged cable. Most of the problems that we have, particularly at the university, were cables. People trip over them, they unplug and plug them in, break the tabs off, the cables back out, use the wrong cable to do those things. Auto negotiation and NIC issues. The default for the NICs that we buy are auto negotiate. The defaults for the switches that we plug them into is auto negotiate. What that means is when you plug them in, they'll communicate with each other and determine what's the highest speed and whether they can be a full duplex or have to be a half duplex when we do those things. So usually just don't mess with it unless there is some problem with it and you have to do a manual configuration. If you have to do a manual configuration, then you need to do it at both ends, because it's still going to be an error message if you only do one end or the other end. And if you change anything, you got to go back and do the manual configuration again. They won't communicate. Ether and fiber issues. errors, drop errors here, the Q errors, the input Qs, the input errors, the output errors. Usually going to be a busy network, too much traffic coming in, bad cable, interference on the cable, causing errors on the data packets that we get for these things. Physical damage, check for them, swap the cable. What's the quickest way to check it? Put a known good cable on the device and see if it works. Swap out the fiber transceiver if it's not working. And that's easy to say. You got to have something to swap it out with. You could go get a known good and put it in, particularly a cable. Plug in a known good cable. Did it fix the problem? Then we have a cable issue. We can then go fix that. Most of, and I said most of what we had actually was at layer 1, was in the media area for those things. Occasionally, a NIC would fail. The new NICs rarely ever failed. Verify, fix the patch panel connections or the media converters. Try the cable in another port. Is the port bad? What are we going to do? Not all damage is visible. And this says use a TDR, time domain reflectometer, which will send a signal down the cable and tell you how many feet down the cable the problem is with it. These are devices that aren't inexpensive, but they do work. The duplex mode, half or full duplex, they have to match. The reason is the full duplex doesn't expect to have to wait for anything. The half duplex is going to be on a timing system, kind of like what we saw this morning on the timing for the signals when it gets there. And the half duplex receives packets at unexpected times. It's going to consider them to be collisions when we do these things. If we have a mismatch, the port's going to be put into what's called error disable mode, and we'll see that a lot as we go through these things, or at least some as we go through these things. It's basically shut down, but it's error disabled, error or disabled on the port when we have a duplex mismatch with these things. Collisions, we talked about them earlier. Show interface Ethernet is going to display the number of collisions. And again, on a switch, we don't really expect to see any collisions. Common for half duplex, may indicate a highly utilized link or a duplex mismatch if we have those things. The switch, the full duplex switch, we don't expect to see any. Late collision occur. Two devices transmit, neither detects the network propagation. Occurs within the first 64 bytes of the data stream. Most of the errors or collisions are going to occur within the first 64 bytes. 16 consecutive late collisions, it's going to give up, drop the packet. It's not going to try to resend it anymore. The random back off and then the retry, how many retries do you get here? 16 is going to be the issue with it. Excessive noise, more CRC, cyclical redundancy check errors. For do these things, cable damage, signal reflection, which we should not have in a twisted pair, only if we were using coax and we didn't have the terminators on it. Excessive collisions, generally a slow network performance. Show interfaces, Ethernet collisions. In order to do that, use a TDR. Late collisions, cables are too long, too many repeaters. Could be in there. Excessive runt frames, underruns could be bad NIC software, and then the no link integrity if we have the wrong wire type configured. Verify both endpoint devices are using the same speed and duplex. Specific issues, mismatch in speed, mismatch in duplex, and we'll look at some of those a little bit later. I've got a packet tracer set up and a visual to show what happens when we have the multiple mismatches. I wanted to